Today we're going to take the first steps in figuring out how to, without using graphs, how to evaluate integrals, and that's starting with indefinite integrals. So let's define what that is. An indefinite integral is just the integral of some function with respect to some variable, but you don't have any limits of integration, so there's just nothing there, here and here. That's all that means, and indefinite integrals and antiderivatives are connected. Let's review what an antiderivative is before we move on. This section is going to hopefully be pretty easy, but we'll see. The definition of an antiderivative is very, very simple. It's just a function, capital F of x, or just any function, such that f prime of x is equal to whatever function. So if, let's think about this, a function f of x, capital F of x, is an antiderivative if you take the derivative, this is an antiderivative of f of x if you can take the derivative of this and you get that. That's pretty much antiderivative. It's the step before you take the derivative. So if you have an antiderivative and you differentiate it, you get back to your original or your regular function. So yeah, the way we were thinking of it before was it's the function, the original function before you get a derivative. It's just the step before it. So if we're thinking about like velocity, acceleration, and position, if you have the velocity function, the antiderivative is the position function. It's just the function before it. Hopefully that's easy to understand. One last note before we move on is that the indefinite integral gives the set of all antiderivatives for a function. So let's write that down. So the indefinite integral gives a set of all antiderivatives for a function, meaning if you have an indefinite integral, all you have to do is find the antiderivative and a little something else, and then you're done. So indefinite integrals are pretty simple. So let's take a look. If the indefinite integral gives the antiderivatives, we're going to take a look at our first example. So here we're going to find the indefinite integral of x to the 7th, just a simple polynomial. So that just means find the antiderivative, find the step before this. And there's a really simple way to figure this out, but let's just think. If we have a function, so don't write this down. Actually, you can write it down if you want to. The power rule for derivatives, that means if you take the derivative, d dx, of some polynomial x to the n, well, remember, you just bring down the exponent and then subtract 1, right? So that would be n, right, n in front, and then x to the n minus 1. Well, if you're getting the antiderivative, you're just going backwards. So the antiderivative formula is just simply going in the backwards direction, and it's this formula right here. However, we have to add a constant, and I'll get to y in a moment. But there's the formula, and let's apply it to this example. So if we have x to the 7th, and we're trying to follow this, that would mean I would take the exponent. N is 7, so I'll take the exponent. So the integral of x to the 7th dx. That's going to be x to the n plus 1, so x to the 8th. And then out in front, we're going to do 1 over 8. And then we have to add a constant. Why do we have to add that constant? Well, if we take the derivative of this, remember an antiderivative is just when you take the derivative, you get the whatever function that you want. If we take the derivative of this, that's the way we can check it. So if we take the derivative of 1/8 x to the 8th, well, this would come down. You would get 8 over 8, right? 8 over 8. And you would subtract 1 from the exponent, so it'll be 7. But, maybe I should have put the constant in there. And that's just x to the 7th. Right? If you take the derivative of a constant, it goes away. So we have to, the constant may be 0. There's an infinite number of antiderivatives for a function just because you can always add a constant. And when you take the derivative of the constant, it goes away. So the answer for all of these is with a plus c. The c is just a constant. And there we go. That would be the antiderivative. That would be the answer. That's just the power rule. It's easy. There you go. This is the important part of this. If you have a polynomial, maybe I'll do another one. You check by differentiating, but you use this rule. Let's do another one real quick. So find the indefinite integral of this polynomial. This is how I do it. This is what I do. I just take the exponent and I add 1, so that will become a 4. And then that has a coefficient of 4, and I put 4 on the bottom. But that cancels out. Sweet. So really, that goes away. And then plus, well, I take 1 to the exponent, or I add 1 to the exponent, so it'll be x to the 3rd. And then, well, that has 6 and a 3 underneath. I put the 3 underneath. I keep that coefficient. But however, like this reduces to 2. Whoops. To 2 minus, I keep that exponent, or no, I keep the coefficient. This is an exponent of 1, so I add 1, that's squared, and I put it over 2. This doesn't simplify, so I leave it like that. And then this is like an x to the 0, correct? Yeah. So what do? We add 1 to the exponent. You keep the coefficient, 3 x to the 1. You just tack on an x. And then also a plus c. Now, what I do in my head, every single time I do this, I write this out, try to simplify stuff in my head, and then I check it in my head. What is the derivative? So check in your head. What is the derivative? Well, the derivative of x to the 4th, it would be 4x to the 3rd. And that's what I have. Okay, good. I did that part right. What's the derivative here? That would be 6x squared. And that's what I want. What would be the derivative here? I bring the 2 down. It would be 14 divided by 2. That's 7. So it's minus 7x to the 1. That's what I have. What's the derivative of 3x? 3. And then what's the derivative of any constant? 0. So I don't have any other thing. So that's how I know I did it right. You're just taking antiderivatives, and there you go. That's pretty easy. That was just the first antiderivative formula. I'm going to... in the next video, I'm going to write down a list of all these formulas, and then we'll just apply some in a couple of examples, and then that's it. We'll be done.